Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. I hope you saw the previous video in which I posted some questions of adding and subtracting fractions, and that was a special case of fractions in which the denominators are co-prime. That means the denominators did not have a common factor between them. If you have not seen that video, please see that first because that forms the base of this trick as well. And this is going to be even more amazing. What will happen if the denominators are not co-prime? So when the denominators are not co-prime means they have a common factor between them. Just like 4 and 10, 4 and 10 are not co-prime because 4 and 10 are divisible by a common number 2, right? So in such denominators, addition and subtraction of fractions become even more easier, and you can do it without taking LCM. Yes, I mean it, without taking LCM. So watch the entire video. I know after watching the entire video, you will be very resourceful and you will be adding and subtracting the fractions virtually orally. No LCM trick for adding and subtracting the fractions. This trick is a part of our ebook of short tricks, which is in chapter number 5, Art of Manipulating the Fractions. And you will be surprised to know that this ebook contains over 350 such smart methods to crack all the calculations and to crack the multiple choice questions in quantitative aptitude with ease. So friends, how to get a copy of that? You want to know? Just send me a message on WhatsApp. This is the WhatsApp number 9896369963. All these details which I have written here, they are in the description of this video also. So friends, let's add and subtract fractions now and enjoy this trick. First of all, we should know the concept. What is going on? So what is going on here is I am going to eliminate that common factor between the denominators. You know what happens when we eliminate a common factor? Just like if you have 4 and 10, okay? So I want to eliminate the common factor between them. What is the common factor? Common factor between 4 and 10 is 2. That is the highest common factor of 4 and 10. Now if I divide 4 by 2, I get a 2. And if I divide 10 by 2, I'll get a 5. So I want these numbers which are co-prime. See, 2 and 5 now are co-prime numbers. Earlier, the numbers which I had in the denominator 4 and 10, they were not co-prime. So if I remove the highest common factor by dividing both numbers by the highest common factor, then the numbers which I obtain are co-prime. And once you get co-prime numbers in the denominator, the adding and subtracting of fractions become very, very easy. I'll show you using a very simple example first. Suppose we have 3 by 4 and I want to subtract 1 by 8 from that. See, very easy. You all know that the LCM of 4 and 8 is 8 only. But I want to demonstrate the method here by eliminating the highest common factor. So you can see 4 and 8, they are divisible by 4 or they have a HCF of 4. So I will remove the 4 first. 4 ones are 4 and 4 twos are 8. So instead of 4 and 8, I will think about 1 and 2 now. So what am I going to do? This 3 will be multiplied by this number. So it will give me a 6 minus 1 will be multiplied by this number 1 itself, and in the denominator, very, very interesting thing. Either do 4 times 2 or do 8 times 1. You will get the same number every time. So 4 times 2 is 8, 8 times 1 is 8. And that 8 actually is the LCM of 4 and 8. So you got the LCM without actually having to find the LCM using the traditional approach. And you get the answer. This is 5 upon 8. Now if you subtract this, you will get 5 upon 8 as the answer. Now this is what we need to do when the denominators are non-co-prime. Let's understand it using some more examples. So you can see 8 upon 9 plus 2 upon 3. 9 and 3. The denominators, they have a highest common factor of 3. So I will divide both of them by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. And now cross multiply like this. 8 plus cross multiply like this, 2 times 3 6 upon, either do 9 times 1 or do 3 times 3, you get a 9, and so the answer is 14 upon 9, or you can reduce it to a mixed number form, 1 5 by 9 will be the final answer. So very easy, no LCM required. Likewise here 10 and 5 they have a HCF of 5, right? So if you divide this by 5 you get 2, divide this by 5 you get 1, cross multiply, 7 times 1 7, 3 times 2 6, and in the denominator 10, both ways it is 10 only, so 10. So your answer for the question 1 over 10. See, so quick. Now let's do some higher calculations. Here you can see we have 3 different fractions and we will use the same method to find the sum and difference of these 3. So first of all I will take 7 by 8 plus 1 by 2. So they have a HCF of 2. So if you divide this by 2 you get 4. Divide this by 2 you get 1. So 7 plus 4 upon 8. So this is 11 upon 8. And we have another thing here, minus 3 upon 6. Now 3 upon 6 can be reduced to 1 upon 2. So we can write 1 upon 2 here. Or if you did it in the initial step itself, it would have got cancelled and the answer would have been 7 by 8. But I will still do it here. Eliminate the common factor 2. So you have 4 and a 1. So this is 11 minus 4, which is 7, and 8 both ways. So the answer is 7 by 8. Likewise in this question 4 and 5 15. So 4 by 5 and 8 by 15. So we have 5 as a common factor. So 1 and 3. Cross multiply, 12 minus 8 upon 5 3s are 15 or 15 1s are 15. So 15. So this gives me 4 upon 15, and then we have plus 9 upon 10. Again common factor 5. So 5 3s are 15, 5 2s are 10. So what do you get here? 8 plus 27. And in the denominator either 15 into 2 or 10 into 3 gives you a 30. And your answer for the question will be 27 plus 8, which is 35 over 30, and which can be reduced further to 7 upon 6. And that is the answer for the question. Likewise, you can go on and on and try so many different questions, and the method will work wonderfully well for all the questions. And these are smart methods, you know. If you follow this method, you don't have to take LCM using long methods. Let's try 1 or 2 more questions. Here we have 7 and 14. They are not co-prime, so 7 1s are, 7 2s are, right? So 5 2s are 10 plus 9 1s are 9, and 14 both ways, minus 3 by 4. So this will be 19 upon 14 minus 3 by 4. 4 and 14 are divisible by 2. So this is 7 and 2. 19 2s are 38 minus 3 7s are 21 over 14 2s are 28, or 7 4s are 28. So answer for the question will be, this is 7 and 1, 17 over 28. That is the answer for the question. One more question here. Now I will do 8 and 16 because 11 is a prime number, so it will not divide 8 and 16. So I will do 8 upon 11 plus 9 upon 16 minus 3 upon 8. See, I just shuffled the terms because I need to do this first. So 8 is the common factor. 8 2s are 16, 8 1s are 8. So 8 by 11, and then plus, this is 9 minus 6. 9 minus 6, 3 over 16, right? So 16, and now the denominators are co-prime. So you just use the butterfly method, right? So 16 times 8, you have 80 plus 48, 128 plus, this is 33, and in the denominator you have to multiply like this. So 160 plus 16, 176. So your answer for the question will be 128, 158, 161 over 176, which is the final answer for the question. See, how wonderfully the trick works, and you can evaluate such huge fractions with so much of comfort. So LCM method, yes, it is traditional and you should know the logic, but when you have to crack the competitive exams, this is all about smartness. So friends, if you're liking all these videos, do share it among your WhatsApp group so that the channel reaches more audiences who are interested in mathematics and who love short tricks. Do subscribe our YouTube channel and click the bell shaped icon for getting all the notifications on your mobile. Practice both the methods which I posted in the previous video and in this video, and let me know, did it work for you? All the best.